They love you, that's why. And that's okay. I mean, I love you too. So, y'all, first thing we want to do is what? Think. What do you want to do first?
Maybe like 9 minus 2 or something.
Nope, do not say 9 minus 2. That is a common mistake. You cannot do that. They're not like terms, okay? No, that's what a lot of people do though, so I'm glad you said it. Don't do it. Split it, which is what you were going to say, divide the 48. Because this right here can be split. The square root of 16 times the square root of 3 is 48. How in the world did you get that, Miss Brister? Look at this list of squares on the board here. Since 48 is not a perfect square, I have to see what is the biggest perfect square that can go into 48. And whatever's on the outside, recall, we just bring that down every step of the way.
Would you divide that 4, 5, and 9? 16's gonna turn into a 4 and a 4, right?
No, you would multiply once they come down with the radical. I see what you're saying. So yeah, if you want to finish this here, I'll go ahead and do that. But I was going to simplify this part right here because I like to make sure I get the whole row worked out before I do anything else. 108, that's going to split into, I believe, 36 and 3. Then, yeah. And now the numbers that we simplify. When you simplify your radical that's perfect, you multiply by whatever's already out there. This will become 4. So 4 times 9 gives me 36. And I'm going to leave this alone. And then this will become 6. Cross out the radical. And what is 6 times 2? Well, it's going to be 12. Since there was a negative sign, I bring down that with it. The radical 3 stays the same. Now you have what I call like terms. They both have a radical 3. It's kind of like if I had 3x and 3x, you'd say 6x, right? So here, when I subtract, yes ma'am, I'm going to get 24 on the outside, but you leave the radical 3 alone. There's your first answer. You know it's right because I said so. Got it? Okay, so number 2 is actually like this. I didn't circle it, but the difference with number 2 is that you're looking at cubes, so just make sure when you work that on your own, you look at the list of cubes. I circled number 3, so let's look at that one. This one's gonna have all of them that can be simplified, yeah. So, copy the problem down.
Is that a 5?
It's a 5. I'm gonna try my best to use my best handwriting, but obviously it's not that good today, I see. Ooh. All right, let's get to simplifying. I'm gonna bring down the 5, okay? But then I'm gonna split 162, and that becomes the square root of 81 times square root of 2. Get it? 81 times 2 is 162. And then I'm going to bring down my 3, and I gotta split the 28. What is the 28 gonna become? The square root of? What times what?
What are these?
These are squares, yeah.
Oh.
So what is the biggest perfect square that can go into? It's not 14. 14 is not a perfect square. 4 and 7. Yes, 4 and 7. 4 is a perfect square. And now I bring down the 8. And I need to split the 18. What are my squares that can go into 18? Look at your lists. 9 and 2. And now I go back to everything that's a perfect square. I'm going to cross it out and multiply by what's there. So the square root of 81 is 9. And 9 times 5 is 45. Leave this. The square root of 4 is 2. And 2 times 3 is 6. Leave the radical. And now I need to do the square root of 9. And 3 times negative 8 is? Good job. Leave the radical. And then let's look for our like terms. We have 2. And that is correct. It is 21 on the outside. Leave the radical 2. But then what do I do with the other part?
Leave it. Just add.
just bring it down. You can't do anything to it because the radicals are not the same. You're gonna have these two things left over, that's it. You cannot add radicals unless the radicals have the same index and number inside. Alright. Let's see, did I circle number 4? I feel like I circled number 4. But then it's like, I almost think that you don't really need number 4 because, you think so?
I think so.
Yeah, we need all the work.
I mean, I said no, the reason I say no to number 4 is because it's the same thing we've been doing, it's just with fourths this time. So, it's like, the more you do, the muscle memory starts to kick in for some of these numbers, you memorize it. That's why when you guys complain about doing a lot of problems of homework, I'm like, well, how are you ever gonna memorize them if you just only do 1 or 2 problems? Every time you do, it's gonna be difficult. I'm gonna go to number 4. Would y'all say you wanna do that? And this is the fourths. You have to look at the list of fourths. Ready? Here goes. What is the invisible number that's right here? So I just want you to know I'm going to bring down this here, and there's nothing I can do with this, so I'm bringing that down as well. No, you do not have to put a -1 there. I'm just doing it because hopefully it'll help you when we get down to the split, and you can see my light turns. Now I'm going to bring down the -6, and I have to split this because the 4th root of 162 is going to become 81 times 2. Yeah, 81 times 2. And then I got to bring down this, and I'm going to split the 32. It becomes 16 and 2. So yeah, 16 and 2. Now I'm going to go through and cross out anything that's a perfect fourth and multiply it by what's on the outside. So this, there's nothing to do. Just bring it down, okay? Well, this becomes, the 4th root of 81 is 3. And 3 times -6 is -18. So I got the 4th root of 2 left in the radical. And now I'm going to do the 4th root of 16, which is 2. So 2 times 8 is 16. And bring down the radical. Look for your like terms. That's all of them. You got it. So that means I got -1 minus 18 is -19. And then -19 and positive 16 is a -3. So -3 is the outside. And then the 4th root of 2 stays in the inside. Stop and process that. Yes? Every time we do these, we're splitting, okay? I know I did not circle number 5, but I want to do number 5 because I feel like it's good if I do that one before I get to number 6, which I know I circled. So for number 5, go ahead and copy that one down. I will not do every problem on the sheet with you. And like I said, if you want to work ahead, you may do so. When I'm done, I'm done. And then you will be on your own. All right. Outside times outside, inside times inside. So that means I have 7 times 1, which is 7. And then I have the cube root of 16 times 8, which is 128. I have to leave the 7 alone, but then I'm going to split this.
So we don't multiply those 2 threes.
What do you mean? Don't multiply what things?
I said the 2 threes.
Oh, no. You keep the index alone and just multiply what's in the radicals alone. So I'm going to have, it sure is, 64 and 2. And the 64 is perfect. I'm gonna say 4th, I'm sorry. The cube root of 64 is 4. So that means I have 4 times 7. And I leave this in the radical. Yes? Alright, so I think number 6, I see number 6 is circled. I'm going to write this over and copy the problem. When I get done, I will leave the screen up though. Alright, so, this looks hard. What do you think you're gonna do first? Well, I like that. She's thinking, do we simplify the 20 and the 30? You could try to, but the thing is, I'm just like, by looking at it, I know it'd be 4 times 5, and the other one doesn't have anything that can go into the 30. So I would say do something else first. Thank you. Distribute. This times this times this. Inside times inside, okay? So the square root of 5 times the square root of 20 is the square root of 100. Get it? Because 5 times 20 is 100. And now I'm going to do the square root of 5 times the square root of 30. And don't forget some minus sign in there, okay? So we'll put a minus sign in between. And then I'm just going to bring down the square root of 6. Now I can start simplifying. Because if possible, I want to split these. And I can, because I see both of them can be simplified. What is the square root of 100 become? And then, do you know what this will split to become? I'll give you a hint. 25 is 1. Yeah, because 5 times 20 is 100. It's inside times inside.
25 and 6.
It is 25 and 6. So I bring this one down. And now I'm going to stop and think, what can I simplify? What can I simplify? Well, you can, but you first have to do the 25, square root of 25, okay? Because square root of 25, I think I heard somebody say is 5. So I'm just bringing down the negative with that though, because it was a negative, all right? And now I got this here. So, do you see how I got from this step to the step right here? There's only one more thing I can do. When you say add it, technically it's going to be subtracting, but yeah. Because the 10 stays by itself. But then you have to have negative 5 plus 1. Because there's a invisible 1 right there, okay? And you negative 4. And that's going to be on the outside. Leave the radical 6 on the inside. Yes? I know, it's a lot. You're processing. Just tell me what you're thinking. What you thinking, baby?
So where did you say,
I thought you were like processing and looking and thinking.
did you say where you got the 4 from again? 5 minus 1?
Where'd I get the 4 from? Yes, negative 5 plus 1. Yeah,
So what about
negative
the
5.
6 after
This one right here, I brought it straight down from right above.
I'm saying like, you got 1 in the solution, so
Let me see if I understand what row you're talking about. Are you talking about this row right here? You're talking about this row right here. Okay, so you understand where the 10 came from, right? You understand where the negative 5 came from, right? So your question is about the radical 6?
yeah,
Or the other
you
one?
have 2 on
Like, why is
it,
not
but
in
then
the
it's
solution?
Why is not in the solution?
Why is 1 not in the solution? Okay, I see. I think I see what you're saying. You understand where it came from, but like, see how right here, this is a negative 5 attached to a radical 6, and this is a 1 attached to a radical 6. Those are like terms because they both have a radical 6. So if I had 6x, or no, let me not even do that. I'm going to use the same thing because that might help you visualize. If I had negative 5x, positive 1x, it would be negative 4x, wouldn't it? That's how I got the negative 4 there. And I just brought the radical down. So you keep the same variable, in this case, you keep the same radical, that's 6, but then I just do something with the coefficients in front, that's it, okay? Now, that answer your question? You're asking really good questions, by the way. Get off your phones, fam. I need everybody focused and locked in. So now what we got for number, what's wrong, babe? What number? Oh, that's Lynn. Yep, good job, got it right. All right, so Lynn, I'm gonna get you your packet. We are doing our project right now. turn to the page, it looks like this, and working with us, baby, this is the test grade. So, number 8, what's the next one I have circled? Can you guys tell me, oh wait, I hadn't wrote it down yet, sorry. Let me write it down, then you can tell me what you think you do. What do you think this is telling you to do? Do the box. Hey, perfect. You have to do the box. Or foil. I refuse to do foil because it is really confusing with all the radicals and then the numbers on the outside. All of that is just too much. So I love to do this instead. Plus, I need you to see the coefficients. There's invisible math going on here, okay? And it's only gonna matter when it's time to get the numbers inside. Invisible meaning, because there's like,
invisible one.
yeah, there's a 1 here and there's a 1 there.
Yeah.
And the only reason that matters is because when we get to the final part and try to combine like terms, people forget about the invisible 1 and they start doing crazy math. So, anyway, inside times inside. This is gonna be the square root of 25. This is gonna be the square root of 10. This is also the square root of 10. And this is the square root of 4. All of them are positives, okay?
Or you just.
Yes. You know when people say square root of 20, you drive me crazy? But they don't drive me crazy. Because I understand why you would think that way. But yeah, there is an invisible 1 here and an invisible 1 here. So that means these are like terms, but they would be 2 square root of 10 is what this would be when you combine them. And then, you know, this here, both of these radicals are going to disappear because the square root of 4 is 2. The square root of 25 is 5. So I just have 5 plus 2, which is 7. So there's my answer. I don't care which one you put first. You can put the square root of, the 2 times square root of 10 first or the 7, right there. All right, so I have number 9 circled. We are almost done with what I'm helping you with. Let me know if I'm going too fast. I can slow down. If you want to ask me about something, please say something. Y'all. Yes. You know, I know it's a lot. Lynn, I will freeze the screen when I get done so you can get the ones that you missed. So for number 9, go ahead and copy the problem down. And think about the bell work, because the bell work is really similar to this problem here. One of the problems for bell work, I say. Okay. All right. So,
See, I have a question.
like,
Okay, so like, on the board, so when we divide, is it different because like, on the board, we divide these first, right? And then like, other times, we can't add on those times because they have, they're touching that.
so when you're dividing, when you're multiplying like the last problem, it's outside times outside, inside times inside. When you're dividing, it's outside divided by outside, inside divided by inside. So
Add.
when you're doing adding, you have to first simplify the radicals, and they have to have like terms.
Okay, so
So
that's a lot.
that's the only difference between the two.
So it wouldn't matter if it was an outside number touching a radical, it was multiplying.
So if it's an outside number touching a radical, let me just see if I understand. So like if it's a 2 touching the 3.
Times like 4 touching a square root of like 8.
Okay, so if it's something like this, then you would just say 2 times 4 is 8.
Okay.
And then 3 times 8 is 24, and simplify, okay? Ignore that right there, that was just me talking to her. It's not any of the problems, okay?
Basically, this one, is this the one like where we take the top, the bottom and times it by the,
No, you
Divide.
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 And then
Yeah, so we're gonna divide this here, the outside's -8. And then the inside is, it's still in the radical, it's, 56? Yeah, 56.
So you got the 285.
Yep, divide the 280 by the 5. And now we split the 56. Look at the board on the cube list. Hopefully you know that 8 goes into 56 7 times. So that means it'll become the cube root of 8 times the cube root of 7. And I like to put the one that's perfect first. Just keep bringing down that negative 8, okay? The cube root of 8, just count down from the top, is 2. So this will become 2. And whatever you bring out of the radical, you multiply by what's already there. It is. And I leave the radical alone, the cube root of 7, okay? That's it. That's all. Because sometimes when you're doing it by yourself, you don't know where to begin. And so you have to like concentrate. What are the rules for this type of problem? You know? And that's why I'm telling y'all and I'm asking y'all for you to please look at your notes and example problems so you can kind of remember what did I do that last time. Bless you. Number 10. Did you need number 10 or are you good on that?
We can do number 10, please.
All right. So I don't know how much time I have left.
It doesn't
I need
matter.
you to do this in 5
This is
minutes.
good.
I got you, babe. I'm not definitely doing my time. I mean, after this one.
I can take one.
Okay, so you guys, you know, you can divide this first or you can get rid of the radical first. It's up to you. Because you cannot have a radical in your final answer at the bottom. So right here,
Is this board like multiply by everything?
yes, I would say go ahead and multiply by the radical 15 first. You can do that. But if you want to divide the 28 and the 7, you can do that first. It's really up to you.
Which one's easier?
When I did mine, I divided the outside and I can't remember how I did it. I didn't want to sit here and lie. Oh, here it is. Yeah, I divided it. It's on my scratch board. Forgot. Right here. I divided the outside
Should be 4.
and I got 4. Yes.
Interesting.
Okay. That's all I'm gonna say. All I'm gonna say. So someone in my other class asked me, they said, Ms. Richard, can we simplify the 5 over 15 to 1/3? Yes, you can do that. And then the numbers are smaller. You don't have to, but you can. Would you like for me to do that so the numbers are smaller, or do you want to just work from here?
Wait, this work?
Which one is it? The numbers are just smaller when you simplify it
But I
first,
feel like we're gonna remember that.
but you might not remember that. So simplifying it is something that you would probably want to remember on your own. I know you can remember to multiply by the radical 15. So I'm gonna do that on the bottom and on the top. When you do that on the bottom, and y'all don't forget, we still have a 4. I don't want to forget the 4. And now on the top is going to be the square root of 75 over the square root of 225. You know 15 times 15 is just 225, okay? So now I'm going to simplify all of this. The 225 becomes 15. You understand where I got the 15 from?
What is 4 doing?
I was just about to say, do you know why I put the 4 at the top?
Wait, well, how'd you get
Because the square root of 225 is 15. Do y'all know why I put the 4 at the top? Because the 4 that's right here has an understood invisible 1 underneath it. So whenever you are putting the 4 with the answer, the 4 has to be on the top. I could have just left it, you know, large in front of it. It's the same thing equivocally, okay? And now I have to split the square root of 75 because the square root of 75 is, oh, I'm running out of space. The square root of 25 times the square root of 3, okay? Do you understand? I took this here and I got this and this. Got it? Do you know what the square root of 25 will become? So that means this will now be a 5. Anything you take out of the radical, you multiply by, excuse me, what's already on the outside.
So
do you do 4 times 20?
So it's 4 times 5, which is 20. And then it's times the square root of 3 all over 15. Do you notice anything about this answer?
It's great.
It's great, it is great, but you can simplify it because 20 and 15 are divisible by 5. This is why I said you might want to divide by the 5 first here, because the numbers become smaller. If I had wrote 1/3, see like right here, if I simplified this first and did 1/3, then I would not be doing this step that I'm fixing to do now. But it's okay if you didn't see it, because you just gotta remember to do it at the end. So when I divide the top and the bottom, let me write this down, divide by 5, this becomes a 4, this becomes a 3. So I have 4 times the square root of 3 over 3. 4 times the square root of 3 over 3. Y'all are really processing on that one, I can tell. Sure. I will end it up with 12, and I will post this video. So if you want to go back, you can see it, okay? I will post this as well. You really need to pay attention. You really do. This is, like I said, the hardest thing we will do all year long. I at least hope it will get easier. You will start that. No, just times the 2 on the outside. Outside time, outside, inside time, inside. So this is the problem. Copy down. I need to get rid of the radical on the bottom. Y'all, you really want to write small for this because you're going to end up having to do 2 boxes. So write small. How do I get rid of the radical at the bottom? The conjugate 2. There you go. 2 minus radical 5. 2 minus radical 5. And you guys, this is going to require you do FOIL for both. So I'm just going to do the box. And I want to put my numerator in this one right here. So in case you're wondering what I'm doing, I'm taking this here and putting it with the box that I'm about to draw here, okay? So those are the ones that go with that. 6 minus 3 radical 5. 2 minus radical 5. Pay attention to your signs. Outside times outside, inside times inside. Do you know what I mean when I say that? Okay, you'll see. So first, I have 12 in this box, and then I have a -6 on the outside, and a radical 5 on the inside. -6 here, radical 5. And then at the bottom, y'all, negative times negative is a positive. And 5 times 5 is 25. So I'm going to simplify anything that can be simplified. You know the square root of 25 is 5. So 5 times 3 gives me 15. This box is 15. And 12 plus 15 is 27. So I have 27. I'm on the top right now, okay? And then these are like terms. -6 minus 6 is negative. Not 1. -6 minus 6 is negative. It's negative 12. Right. And then I'm going to leave the radical 5 touching. And now I'm on the bottom. This needs its own box as well. So I'm going to draw one more time over here. This okay, outside time outside, inside times inside. 4. -2 radical 5, +2 radical 5. negative square root of 25. Alright, look at my numbers, look at my math. And we better get some canceling out here, cause the radical has to go away. So that means this here is gone. And then y'all, do you know what square root of 25 is? It's once more. And there was a negative sign there though, so what does that mean? It's a negative 5. So this is negative 5, this is positive 4. Am I gonna leave it like that? Do you think I'm gonna leave it like that? No, you can't multiply, you're right. But you need to divide it.
Oh, yeah.
So, well, you're gonna divide negative 1 into 27, and then this right here, okay? So, basically, it'll be just negative 27, and then a positive 12, and radical 5. That's all, just divide.